this is going to be our first section. It's on section 1.2, points, lines, and planes. Alright, first thing we need to do is go over some vocab and just the basic parts of geometry. It has 3 terms that are called undefined terms. Alright, it means they have a description, but they don't really have a definition. Alright, so you can describe a point. Alright, this is a point right there. It looks like a dot. Alright, but the thing about a point is it has no size. Alright, we can say that it's in 0D. It has 0 dimensions. Alright, it doesn't go up, down, left, or right, forwards or backwards. It's just kind of a spot in space. Alright, we name a point by a single capital letter. Alright, so this is a capital A, this is point A. Alright, a line is represented by a straight path that extends in 2 opposite directions, and it has no thickness. Alright, so even though you see this line when it's drawn, it has thickness, the line itself really doesn't. It's a bunch of infinitely many points. So that means that you got point, 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 point. And they all come together. Eventually, in infinitely many of them, they make a bad arrow. They make a line. All right. We say the line has 1D. It's got 1 dimension. It's going left and right, but it's only 1 dimension. All right. To name a line, you got a couple of options. You can name a line by any 2 points on this line. Only 2. It can have more than 2 on the line, but only pick 2 to name it. All right, so this could be line AB, or this could be line BA. Also notice this lowercase cursive letter at the end. We can also name this line L. All right, notice with line L, we don't put the line above it. We write out the word line. All right, so those are your 2 main ways to name a line. You can name it with 2 points, or you can name it with your lowercase cursive letter. A plane. All right, a plane is a flat surface that extends with end, and yet again, it still has no thickness. So it's not going to have any depth to it, but a plane can go up and down, and a plane can go left and right. So we say a plane is in 2D. All right, you can name a plane 2 ways. You can name it by this capital letter sitting in the corner by itself. You notice how this letter is different than A, B, or C? A, B, and C all have points. P does not have a green point, so I know that's the name of my plane. Or we can pick 3 points, all right? So 3 points that do not lie on the same line. All right, that's a kicker. They cannot be on the same line. So A, B, and C, they're not on the same line. Those are great points to name that plane. All right, so let's go through this. What are 2 ways we can name line QT? All right, so here's my Q, here's my T. So I'm looking for the name of this line. All right, well, we can always switch it up. We could go line TQ. And again, since we're naming it with 2 points, we got to have our line above it with arrows. All right, notice if we keep going, whoa, look, there's another point on this line. It's N. So I could even name my line NQ. I could name it line NT. All right, and if I keep going, notice there's a single lowercase letter here. I could name this line M. All right, all those are great ways to name that line. What are 2 other ways to name plane P? All right, P sitting over in the corner by itself. So I need 3 points that are not on the same line. So let's look around my plane and look for some points. All right, so how about plane R? I definitely didn't spell out the word plane. P-L-A-N-E. There you go. Plane R Q-S. Does that work? Are those 3 points not on the same line? Nope, not a good name for that plane. All right, so how about R-Q-V? All right, V works. Those 3 points do not make a line. How about plane S-Q-V? 3 points, not on a line. Works good. New vocab word here. Let's break it down. What's the prefix co mean? Together. Good job. And linear? Any ideas? Maybe right there in the word? Line. All right, we need 3 points that are together on a line. So I have line right here with 3 points. So T, Q, and N, those are 3 collinear points. Or I've got a line right here. How about R, Q, and S? Those are 3 collinear points. Okay? All right, 4 coplanar points. Let's break it down again. Co means together. Planar. How about on a plane? I need 4 points on a plane. All right, so my only plane here is plane P. So my 4 points on plane P are R, S, Q, and V. So those are my coplanar points. All right. More words, more vocab is a segment. All right, a segment is a part of a line that consists of 2 end points. All right, key thing there. 2 end points, and all the points between them. So I have an endpoint A and an endpoint B. So even if I threw another point on there, A and B are still the ends of this. All right, so I'm going to name this as segment AB or segment BA. Now notice what goes above this. It looks like a segment. All right, no arrows. All right, a ray is also a part of a line, but this one only has 1 endpoint. All right, and all of the points on the line are on the same side of that endpoint. So A is my endpoint, and B is on my side of my endpoint. So I got all the points on B's side. So this has an arrow because I want all the points that keep going on into infinity. Now, I'm going to name this ray AB. Now, notice it doesn't give you the option here for ray BA. And here's why. Ray BA means that B is the end. So B is the end, and then A is the side. So it would look like that. That doesn't work. All right? So these two are not the same. You can only name a ray one way, with the end point first. Opposite rays are exactly what they sound like. It's 2 rays that go in the opposite directions. Here's the key kicker on this one. They have to have the same end point. All right. So if I have ray CB going this way and ray CA going this way, and they have a common endpoint at C. So those are my opposite rays. All right, name the segments in this figure. All right, so segments are part of a line that have endpoints. So, like DE is a segment. EF is a segment, and so is DF. Now, remember when naming a segment, it doesn't have to be DF for Dutch fork. It could be FD. It could be FE, or it could be segment ED. All of those are great segments in this lovely picture we have here. All right, what are the names of the rays? All right, so a ray has 1 end point, and we need to know the point to know the side of the line. All right, so if I choose D as my end point, the side that I have points on is to the right, so I have to pick one of these points. So I can name it ray DE, or I could name it ray DF. Those would be the same rays. Now, what if I pick, let's go with F as my endpoint. If F is my endpoint, I have to go to the left. So I can name that ray FE, or I could name that ray FD. Now, what if I picked E as my endpoint? If E is my endpoint, I could go towards F for ray EF, or if E is my endpoint, I could go towards D, so that I could have ray ED. All right. Now the question is, which one of these are opposite rays? Which one of these have the common endpoint? These guys, woo, right there. Ray EF and ray ED are opposite rays. Now, a postulate. This is a new vocab word. It's a statement that is accepted true without proof. So, when you were a little kid, someone told you the sky was blue, and you just learned that that color was blue. You just believed it. No one had to prove it to you. It's just blue. All right, so these are things in geometry that we just believe are true. No one proves it. We just go, yeah, that makes sense. I can work with that. So here's our first postulate. Through any 2 points, there is exactly one line, which makes sense. You got a point A and a point B. If you play connect the dots, there's only one line that will play connect the dots with those. All right, so if you've got 2 points, only one line can go through them. Here's our next postulate, 1.2. If two distinct lines intersect, then they intersect in exactly 1 point. All right, let's break this word distinct down. That means if I have a line here, and if I have another line here, act like those overlap a lot better than what they did. And if I had another line here, another line here, another line here, and all they do is overlap each other, those aren't distinct. All right, distinct lines mean they're not overlapping. All right, they're not the same line. So we got 2 separate lines. When they intersect at exactly 1 point. So these 2 lines have 1 point in common. It's point C. Another postulate. If 2 distinct planes, again, they got to be separate. If they intersect, then they intersect in exactly 1 line. All right, so we have our blue plane, plane RST, and we have our orange plane, plane STW. If you see where these guys intersect, it's right here. All right, but since planes keep going forever and ever, so would this. This would make a line. It would keep going forever and ever. So plane RST and plane WST intersected line ST. All right, postulate 1.4. Through any 3 non-collinear points, there's exactly 1 plane. All right, so what that means, let's break it down. Non-collinear. Co meant together, linear means line, and non means they're not. So it's points that are not together on a line. They cannot make a line. So really you want to look for 3 points that make a triangle. All right, so points Q, R, and S are not on a line. So that means that these 3 points can make a plane. They make plane P. And last but not least, let's see if we can find some planes. What plane contains N, P, and Q? So here's N, here's P, here's Q. All right, so that plane is this one down here. It's the bottom of this box. Now, notice my question did not include my other corner, which is R. It could have. You could pick any of those 3 points, and that will make a plane. So you could have used R instead. All right, what about J, M, and Q? All right, here's J, here's M, but here's Q all down here by itself. So, what do I do with that? I mean, Q's over there in the corner, like J and M are up top. Well, really, there's a diagonal plane. Woo, not straight at all. All right, I'm going to erase this line. I'm going to try and draw another one. Hey, there it is. That looks a lot better. We're cutting this diagonal in here to find that plane. All right, so we have a diagonal plane. And last but not least, what is the intersection of plane JMK? So JMK. All right, and K is this corner here. So JMK, that's our top. And the intersection of plane NPK. Well, here's N, here's P, K is that top corner again. So now we're looking at the front. Well, what's the intersection of those? Well, remember that the intersection of 2 planes is a line. All right, so I need to name this line here, and that is line JK. All right, that's about it for today, so I'll see you guys later.